So we are discussing now polarization of waves. Polarization of waves. So let us discuss what are unpolarized and polarized waves. Let's begin our discussion from this. This is a basic introduction. Okay. In general, how many types of waves are there? Can you tell me? The waves can be described as either they are transversal or they are longitudinal. It is important to understand that. Both type of waves, they undergo reflection, also refraction, besides interference and diffraction. All the waves undergo these phenomena. I already explained reflection, refraction, okay, interference and diffraction. However, the only difference between these two is that only transverse wave can be polarized. Remember, only transverse wave can be polarized. Transverse means what? In transverse waves, the particles are moving in the vertical direction, right? And that's why they can be polarized through a certain path. Got it? So, a transverse wave in which vibrations are present in all possible directions. Okay? A transverse wave in which vibrations are present in all possible direction or directions in a plane perpendicular to the direction of propagation. In a plane perpendicular to the direction of propagation. Can you understand this language? The wave propagation, there will be a direction like that. Let's say this is the direction of propagation and vibration is happening like that. Okay. So the plane which is perpendicular to the direction of propagation. So if you are going like this, then this plane perpendicular to the direction of propagation. समझ रहे? So the plane perpendicular would be something like that. Yes or no? समझ रहे हैं इस बात को या नहीं? So a transverse wave in which vibrations are present in all possible directions in a plane perpendicular to the direction of the propagation is said to be unpolarized. Okay, is said to be unpolarized. If the vibration of a wave are present in just one direction, if the vibration or vibrations of a wave are present in just one direction, in a plane perpendicular to the direction of propagation, to the direction of propagation, the wave is said to be polarized. The wave is said to be polarized or plane polarized or plane polarized. Is this discussion bringing some meaning to you? Are you able to understand this language or not yet? Okay. अब आप देखें यहाँ पे आपको क्या समझ में आया होगा और क्या समझ में नहीं आया होगा. हमने दो केस डिस्कस किए, राइट. पहला केस के सबसे पहली चीज क्या है, सिर्फ ट्रांसवर्स वेव ही पोलराइज हो सकती है. पहला डिस्कशन ये है, जिसमें क्लैरिटी है या नहीं है, हाँ या ना. दूसरा हमने बोला कि जो ट्रांसवर्स वेव है, यू आइडेंटिफाई व्हाट इज द डायरेक्शन ऑफ प्रोपोगेशन. ओके, क्लियर. Direction of propagation means in which direction your wave is traveling. Okay, the direction of propagation means in which direction your wave is traveling, and the plane perpendicular to that, there will be a plane. Imagine that there is a plane which is perpendicular to the direction of propagation. Now an unpolarized wave vibrates in all directions in that plane. However, a polarized wave only vibrates in one single direction. I will show you again. In unpolarized wave, now try to, let us make a, let me suppose this is the direction, yes, direction of propagation, and then this is the plane perpendicular, okay, to the direction of propagation. What we are telling is that unpolarized wave will vibrate in all possible direction. ऐसे भी जाएगी, ऐसे भी जाएगी, ऐसे भी जाएगी, you know, in all possible direction in that plane. Okay, is that clear? However, इसके अंदर आप एक रास्ता बना दो ऐसा, तो क्या होगा, सिर्फ ये ही निकलेगी बस इसमें से। सो यहां तक ये अनपोलराइज्ड थी। क्यों? क्योंकि यहां पे ऑल सॉर्ट्स ऑफ वेव्स वर देयर इन ऑल द डायरेक्शन, बट जैसे ही इसको यहाँ पे ये स्लिट से निकली, ओनली वन डायरेक्शन, ओनली ए पर्टिकुलर डायरेक्शन वेव ही अंदर जाएगी, रेस्ट ऑफ देम विल बी ब्लॉक्ड। आर यू क्लियर और नॉट येट? Okay, so here you will get polarized wave. Unpolarized means it is vibrating in all possible direction in that particular plane which is perpendicular to the direction of propagation. And if we give a certain path to it, it will block all other waves which are there in different directions, except only that particular path will be allowed to pass. So resulting wave after that plane will be called polarized wave. Okay, so we will call it source S1 for example. Okay, we can also take yet another source, something like that, similar type. Okay, and we can take it like that, and again ensure that it's fully passing through it. Maybe you can put some kind of mirrors to see if the wave come back after reflection, something like that. Okay, so it will be like this. So it will get reflected, there will be a reflected wave otherwise. However, if the same thing, suppose इसको vertical के बजाय मैं इसको horizontal कर दूं, something like that, and इसको same ही vertical रहने दूं, और ये मेरा vertical ही रहे, like this. So whatever wave I was receiving, like for example इसको थोड़ा सा सेंटर में कर लेते हैं, जैसे ये तो खड़ा हुआ है, और आप इसको ऐसे खड़ा होने के बजाय ऐसे कर दें सेकेंडरी सोर्स को. ओके, सो we can possibly make it like that. Like this. So since we have made it now, instead of vertical we have made it horizontal, will it allow it to pass? So what we were getting, something like that. Here we were getting, but here it doesn't allow you anymore. So you will not receive any wave output over here. Here there is no output. So, and since it is here, it is unpolarized, remember. Why? Because there are other waves in different direction. कैसे? दूसरी waves को भी तुम ऐसे ऐसे draw कर दो, ऐसे, right? Something like that. And there are so many other waves which are going here like that. But what is happening here? Only you are getting one direction, and here you are getting polarized. Here nothing, no wave. You can write no wave. Here since both were vertical and they were having the path, so it was allowed. So you are having a wave over here. So it was polarized. Here you will have the same thing. However, in this case you are getting nothing. Okay. Is the concept of polarization clear? So this is experiment to demonstrate polarization of a wave on a string. Experiment to demonstrate polarization of a wave on a string. This was the experiment that I just explained you. So एक और पिक्टोरियल रिप्रेजेंटेशन डिस्कशन करूंगा मैं आपसे. Suppose this was my plane, vertical, right? So unpolarized wave, how would it look like? It will look like in all direction like this. You are having a wave in every direction, right? Now the way I have made, okay, can you think that the propagation of wave would be possibly into the paper? You can think of it, okay? समझ रहे हैं? Like this. Then you can actually achieve polarized wave using through polaroids, you know. आपने तो polaroids के नाम तो सुने ही होंगे, okay? So and then there are tourmaline crystal and things like that, you know. Nicol prism. There are mainly three: Nicol prism, tourmaline crystal, and Polaroid. Polaroid is a thin commercial sheet जिसके थ्रू हम ये polarized light देख सकते हैं. It's basically is a thin commercial sheet in the form of a circular disc, which makes use of property of selective absorption to produce an intense beam of plane polarized light. Okay, so ये mainly Polaroid का काम है. Now आपको मैं थोड़ा सा और रिप्रेजेंटेशन दिखा देता हूँ कि आपको एग्जैक्टली क्या मिल रहा है. अनपोलराइज्ड लाइट, जैसे मान लो मैंने ये दिखाया, और सपोज यू आर यहां से, ये आपका, लेट मी से इट इज डायरेक्शन ऑफ प्रोपगेशन. ओके, सो व्हाट शैल वी डू? वी विल पुट अ now this time what is it that I have made? Can you think? This is called polarizer. Polarizer. Okay, so here it was unpolarized light. Unpolarized light. Okay, you can show it like this. And then इसी पे ही एक डार्क पॉइंट बना सकते हैं ऐसे, सो दैट बाकी वाली भी दिख जाए तुमको. ये सारी डायरेक्शन वाली यहाँ डार्क पॉइंट से दिखा दो ये, ठीक है, लाइक दिस. और फिर यहाँ एक डार्क पॉइंट बनाओ लाइक दिस, बिकॉज आपको तो सब ऑल डायरेक्शंस देखनी है, लाइक दिस. पोलराइजर यहाँ पे है आपका, और पोलराइजर के बाद क्या मिलेगा आपको? प्लेन पोलराइज्ड लाइट मिलेगी आपको। यहाँ देखिए ऐसे मिलेगा। Now what is the difference? You are seeing that the bold blue जो हमने ये बनाया है, because that is showing you the direction, all the direction. Unpolarized means it's vibrating in all the direction. Okay, but output is plane polarized. Plane polarized light. And if you put analyzer, we can make an analyzer over here like this. So analyzer means you can rotate it, you can rotate it. जैसे कि हमने इसको पिछले जो डिस्कशन में दिखाया था कि हमने क्या किया था, इसको हॉरिजॉन्टल कर दिया था। हॉरिजॉन्टल कर दिया तो नो लाइट वाज विजिबल ऑन द अदर साइड, ऑन हियर। सपोज मैं यहाँ पे ये कहूँ कि भाई ओके दीज आर माय eyes here, right? So if you, the way I have put it here, I will get a plane polarized light which is visible to my eyes with maximum intensity. If मैं अपने एनालाइजर को, ये इसका नाम क्या रखूंगा मैं? एनालाइजर। एनालाइजर एग्जैक्टली सेम ओरिएंटेशन में रखेंगे तो मैक्सिमम लाइट मिलेगी मुझको, या मैक्सिमम इंटेंसिटी ऑफ लाइट मिलेगी एट द आईज साइड। ओके, बट इसी को मैं धीरे धीरे ऐसे ऐसे घुमाते जाऊंगा तो लाइट कम होती जाएगी, एंड जैसे ही हॉरिजॉन्टल आएगी माने 90 डिग्री रिलेटिव एंगल होगा, माय इंटेंसिटी वुड बिकम 0। इज दैट क्लियर? यस और नो? ये समझ में आ गया? हाँ, तो ये जरूरी है। इसी चीज को आप यहाँ पे हॉरिजॉन्टल बना दो तो आपको यहाँ पे क्या दिखाई देगा? नो लाइट। तो यहाँ पे आप देखें, फिर से हम एक यहाँ पे एक ये बना सकते हैं, यहाँ पे, and here let me make my this thing eyes, and we can say this is analyzer. Okay, so this analyzer, so इस एनालाइजर को हम क्या करें? हॉरिजॉन्टल करें? ऐसा तो नहीं लगा सकते ना यहाँ पे, वी हैव टू मेक अ हॉरिजॉन्टल ओरिएंटेशन। So let's make a horizontal orientation. So इसको horizontal कैसे दिखाएं? ऐसे, and then here the orientation remain unchanged. Okay, so now here once again we can see that I am having an unpolarized light. Okay, and then I will obviously get an output like this. और डिफरेंट, इसको पहले तो ये बना लो और फिर डिफरेंट 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 डायरेक्शंस को डार्क पॉइंट से दिखाओ, ठीक है कि नहीं। तो ये आपका, इसको कैसे रिप्रेजेंट कर कहोगे आप, अनपोलराइज्ड, ठीक है, समझने के लिए दिस इज अनपोलराइज्ड light. All right, and then here what you get, you get an output like this. ये directional है, okay, all other sides are blocked, only this direction is allowed, like that. But will you see something here? You will see no light here, no light. Are you with me? जैसे ही हमने horizontal किया इसको, we get no light. So this is the pictorial representation. Now let us learn what is called law of Malus. Law of Malus. When a plane polarized light is seen through an analyzer, when a plane polarized light is seen through a polarizer, or rather we should write here analyzer, okay, because plane polarized light, that means first step we have already taken, second step में क्या होगा, analyzer, okay, through an analyzer, okay. The intensity of transmitted light, the intensity of transmitted light varies as the analyzer is rotated, varies as the analyzer is rotated. Have you understood this statement? जैसे जैसे हम इसको रोटेट कर रहे हैं वैसे वैसे बाहर जो वेव जा रही है उसकी इंटेंसिटी कम हो रही है और वेरिएशन हो रहा है, कम या ज्यादा डिपेंडिंग ऑन द डायरेक्शन, ओके। क्लियर? And analyzer is rotated on its own plane about the incident direction. The intensity of transmitted light varies as the analyzer is rotated, so rotated in its own plane, in its own plane about the incident direction, about the incident direction. Each word is very important, you know, you have to visualize how it is happening, incident direction. Let initial हम कह सकते हैं let intensity I of transmitted light varies directly या हम इसको यूं लिखें कि when a beam of completely plane polarized light, when a beam of completely plane polarized light, when a beam of completely plane polarized light is passed through analyzer, is passed through analyzer, the intensity I of the transmitted light, the intensity I of the transmitted light varies directly as the square of the cosine, as the square of the cosine of the angle theta between, ध्यान से सुनना, between the transmission direction of polarizer, transmission direction of polarizer and analyzer, and an analyzer. So this statement is known as law of Malus. This statement is known as law of Malus. So what did we learn? Suppose I was the intensity, is proportional to cos square theta. Okay, which means we can have proportionality constant as I naught cos square theta. Here I naught is the maximum intensity. Okay, maximum इंटेंसिटी, और कब होएगी? जब थीटा 0 होएगा, दैट मीन्स दोनों पैरेलल होंगे टू ईच अदर, यू नो, तभी होएगी ना. ओके, so I naught is the maximum intensity of transmitted light. Clear? Yes or no? Further, it may also be noted, it is important, it may be noted that I naught is equal to, I naught is equal to half the intensity, equal to half the intensity of unpolarized light, unpolarized light incident on the polarizer, incident on the polarizer. ये एक important statement है. Suppose unpolarized light is I, then outcome क्या होगा? I by 2, which is nothing but I naught. Clear? तो ये रहेगा. So let us now try to understand this whole thing. इसमें जो तुम्हारे स्पेशल केसेस हैं वो क्या बनेंगे? स्पेशल केसेस बन सकते हैं जब आपका थीटा क्या होगा 0, थीटा इज 0, देन और 180 स्पेशल केस, राइट। तो आई क्या हो जाएगा जी, आई हो जाएगा आई नोट, yes, because cos theta will become plus minus 1, cos 0 is 1, cos 80 is minus 1. You can write cos theta is plus minus 1. So that will result in I becoming I naught. Clear? When theta is 90, what will be I? Tell me. Theta is 90 degree, I will be 0. Because cos 90 would become 0 and 0 square will also become 0. Clear? So this is an important understanding. Now also let us learn one more aspect, and that is the point number 3. When beam of unpolarized light is incident on the polarizer. When beam of incident light is beam of unpolarized, यहाँ पे लिख दो बीच में beam of unpolarized light is incident, यहाँ बीच में ये आना चाहिए, is incident on the polarizer, every word is important. Then I would become I naught cos square theta bar, because all directions में है कि नहीं, and minus I naught. Okay. And into half of how much? 1 plus cos 2 theta bar. So what shall we get? Can we simply see cos 2 theta is equal to 1 minus 2 cos square theta, correct? 2 cos square theta is 1 minus cos, no, here it will be 2 cos square theta minus 1, okay. So here it become cos 2 theta, so cos square theta will become this, so here you will have an equal sign, okay, समझ रहे हैं? So you can say so I will be I naught cos square theta bar, which will become I naught, and here we will write 1 plus cos 2 theta upon 2, okay, and this also would be the average, okay, value. One's average will always be 1, so will be I naught 1 plus cos 2 theta upon 2, and average value of cos theta कितनी होती है बोलो? Zero. Very good. So we will say I naught upon 2 plus 0. So my answer will be I naught upon 2. So unpolarized light जब पहली बार polarizer से गुजरती है तो जो आउटपुट है वो क्या हो जाएगा? I naught upon 2. Got it? So that's the way it can be understood.